here are some examples using the Pythagorean identities. So if cosine of theta equals -2/3 and tangent of theta is greater than 1, show how to find the value of sine and tangent using a Pythagorean identity. So first thing you have to envision is that we have a triangle. And in our triangle, we know that cosine is our x. We're looking for sine, so I'm going to make that b squared. And our hypotenuse is going to be 1. And then I also know that sine is going to be negative because in order for tangent to be positive, when I find tangent, I find the slope. So I'm going to divide sine by cosine, and a negative divided by a negative is a positive. So I already know that b is going to be negative, right? So in order to use the Pythagorean identity, I just use the Pythagorean theorem. So I'm going to do -2/3 squared plus b squared equals 1 squared. So that's going to be 4/9 plus b squared equals 1. So I'm going to subtract 4/9 from both sides. So I end up with b squared equals 5/9. So I'm going to take the square root of both sides. And when I do that, I end up with b equals the square root of 5/3. Remember, I said it's got to be negative because tangent is greater than 0. So sine is a negative square root of 5 over, and I want to make that a little bit clearer, square root of 5/3. So to do tangent, I have to divide sine by cosine because it's rise over run. So my sine is negative square root of 5/3. And I'm going to divide it by cosine, which is -2/3. So remember that the rule for dividing fractions is keep, change, flip. A negative divided by a negative is a positive. So I'm really got the square root of 5/3 times 3/2. My 3's cancel. So I'm just left with the square root of 5/2. So tangent is the square root of 5/2. My next example is if I'm given tangent, show the value of cosine using a Pythagorean identity. So this one's a little bit different. I can't just straight use the unit circle. I have to actually just use a regular triangle. So the first thing I'm going to do is tangent is slope. So tangent is equal to the rise over the run. So in this case, sine would be 3, which is my vertical height, and cosine would be 4. So first thing I have to do is figure out what my hypotenuse is. So I use the Pythagorean theorem. I'm going to do 3 squared plus 4 squared equals c squared, because I don't know what it is. 9 plus 16, 25. So I find the square root of both sides. So I get 5 equals c. Okay, so that means that my hypotenuse, I'll draw a new triangle, is c, is 5. So now I have a triangle that's 3, 4, and 5. So when I'm thinking about this, I want to think about that the cosine is SOHCAHTOA. So the cosine I know is the adjacent over the hypotenuse, but I'm looking for the sine, and the sine is the opposite of hypotenuse. So my opposite is 3, and my hypotenuse is 5. So sine would have been 3/5. But the COHCAHTOA is adjacent over hypotenuse, so cosine is going to be 4/5 because cosine is my. Okay. So last example is if pi over 2 is less than theta, which is less than pi, which means that, so if I have my unit circle, pi over 2 is here, and pi is right here. So that means that theta is somewhere in this quadrant. Okay? So it tells me my sine of theta is 1 over 1/2. Show how to find the value of cosine and tangent using the Pythagorean identity. So the first thing I'm going to do is think about a triangle. I'm thinking about my sine is 1/2. I don't know my cosine, and I don't know my cosine would be b. So I'm going to just use the Pythagorean theorem. So 1/2 squared plus b squared equals 1 squared. So I'm going to get 1 over 4 plus b squared equals 1. Subtract 1/4. So I end up with b squared equals 3/4. So I'm going to get the square root of 3 over 2. So b, which is cosine, is the square root of 3 over 2. But it's in the second quadrant, so I know that cosine is negative in quadrant 2. So it's negative square root of 3 over 2. So then it also wants me to find the tangent. So to do that, I do sine divided by cosine. So I'm going to do 1/2 divided by the square root of 3 over 2, negative, which is the same as multiplying by the reciprocal. So I'm going to do 1/2 times negative 2 over the square root of 3. So these are going to cancel out, and I get negative 1 over the square root of 3. And then I rationalize it, multiplying by the square root of 3 over 3. So I get negative the square root of 3 over 3. So tangent is negative radical 3 over 3.